දැන් ටිකක් අමාරුයි වගේ නේද? එක දිගට මේ physics sorry chemistry part එකම කරගෙන ගිහිල්ලා. So shall we start the 18th lesson. Okay, the 17th is the short lesson. We have to discuss about rates of chemical reactions, right? What are the factors affecting the rate of a chemical reaction? ඔය ටික තියෙන්නේ දැන් chemical reactions කරලා පොඩ්ඩක් වැඩි වගේ දැන්. නැද්ද එහෙම? ඔයාලට එහෙම හිතෙන්නේ නැද්ද? පොඩි change එකකටත් එක්ක we'll move on to a physics lesson. Work, energy and power. An interesting lesson. All are interesting one. Yeah, I mean, we have so many calculations here. Right. Work, energy and power. So this can be related with the second unit. The things that you have learned in related to velocity, and also then the fifth unit. No, not the fifth, fourth unit, the Newton laws, right? These are associated. Make ඒවත් එක්ක combine කරලා ප්‍රශ්න අහන්න පුළුවන්. And you have learned about momentum. Here we are going to discuss about the potential energy, kinetic energy, which we call as mechanical energy, and what is work done, what is the power, right? Hari. Work, energy and power. And we have learned about energy. In previous grades also we have learned about energy. So how do you define the term energy? Yes, Kian Balan. Energy. Yes. Ability of doing work. Nathan, the ability to do the work is known as energy. Then you have learned about force as well. Force is either a push or a pull, right? The ability to do the work is known as energy. In order to do a work, we need energy. For example, I need to push this table, right? So I have to apply a force. As a result, the table will make a displacement. The table will make a displacement. Then only I can say that I have done a work. A work is done due to the displacement of an object on application of a force. Then another, the work is done. A vehicle is moving because the engine exerts a force. As a result, it makes a displacement. Therefore, a work is done there. You drag a bucket full of water from a well by using a pulley. So there, we apply a force. As a result, the bucket is displaced. So we have done a work. You are lifting a weight. Then we are applying a force on it, right? We are applying a force against the gravitational force. Then we are able to lift it. A displacement is made. So we can say that a work is done. Terunada? Hari. Enang we can say work done. The position or shape of an object. Monkey position and shape. You have a rubber ball here. You squeeze the rubber ball. So what happens? Its shape is changed. You have a rubber band. You drag, stretch it. Stretch the rubber band. Shape is changed. You have a helix, spring helix. You just stretch the spring helix. You change the shape. You have a bow and an arrow. In order to send the arrow, you just drag the bow, right? So change in shape. So all these in all these instances, we applied forces as well to change the shape. Therefore, we can say that we have done a work. The position or the shape of an object can be changed by applying a force. Then a work is done due to the application of force. මේ බලන්න. Here you are shown a diagram. A work is done on this object by applying a force. So this is the point of application of the force, right? You know, when we are indicating a force, අපි මොනවද consider කරන්න ඕනේ? Grade 9 knowledge. Yes, point of application of the force. And also the magnitude of the force is indicated by the length of this straight line. And also the direction of the force by the arrowhead. So those are important. As a result, this object is displaced from here to here. මේ බලන්න distance measure කරන්න අපි මේ end එකෙන් පටන් ගත්තා නම් ඉවර වෙන්න ඕනේ තේ end එකෙන්ම තමයි. To find the displacement. එමනේ තියෙන object එක. Something like this. So this distance is said to be x meters. The force is capital F Newton. Okay? එහෙනම් we can give an equation for the work done as force multiplied by the displacement in the direction of the force. Work done equals work done on the first equation. Force into displacement in the direction of force. Force into displacement. If we mention the units, force is given in Newton, displacement is measured in meters. Therefore, work done is obtained in Newton meters. But remember, 1 Newton meter is equal to 1 joule, right? 1 Newton meter is equal to 1 joule. Therefore, we can express the work done as in joules. The work done can be expressed in joules. Okay. You can see the question. Just do the calculation. Then calculation එකක් දැකපු ගමන්, if there is an equation, just write the equation and substitute for that equation. Equation එක හැමතිස්සෙම ලියන්න. හරි නේද අදීෂ? Okay, Prahashmita කියලා මම හිතනවා. Prahashmita, I got your message. So if you all have issues with your cameras, please get them corrected as soon as possible, right? What is the work done if a force of 5 Newton acts on an object and displace it by 2.5 meters to the direction of force? On equation work done equals force multiplied by work done equals force into, yes, displacement to the direction of force. Force into displacement to the direction of force. So the force is given as 5 Newton. It displaces by 2.5 meters. So that is 12.5 Newton meters, or you can say that it is 12.5 joules. Then do the next one. Mass of an object is 3 kilograms. Find the work done in lifting it upwards by 5 meters vertically. This is 3 kilograms in mass. So you are going to lift it vertically upwards to a height of 5 meters. Right? So you are asked to find the work done. Yes, Tessini. Upeksha harida? Yes. Right. Gavisha? ඊළඟට third එකක් තියෙනවා. එකක් කරන්න. හරි. බලමුද? So, when we are lifting a mass vertically upwards means we have to apply a force equal to its weight. Now we can say the weight of the object W equals mg. So the mass is 3 kilograms. Therefore, the weight of the object is 30 Newton. So we have to apply a force equal to its weight. Or the weight is also known as the gravitational force. We have to do the work against gravity. So here we can say work done equals force into displacement. Force into displacement. Right? Force into displacement. So the force is 30 Newton. The displacement is considered to be 5 meters. Right? So that is 150 Newton meters. That's 150 joules. Okay? Did you get the answer? Hari. In the third one, it says find the mass of an object on which a work of 180 joules is done by raising it to a vertical height of 4 meters. Here the mass is not known. We have applied a force of 108, we have done a work of 180 joules by raising it to a vertical height of 4 meters. එහෙනම් අපිට ගාන දැන් අනිත් පැත්තට යන්න වෙන්නේ. මේ ඉස්සෙල්ලා ගියේ මෙහෙට දැන් මෙහෙට එන්න එන්නේ. Work done. Work done equals force multiplied by displacement. Force into displacement. Right? So work done is given as 180. Force we don't know. Force is actually the weight. ඔන්න පැත්තකින් ලියා ගන්න. When we are lifting a weight vertically upwards, when we are lifting an object vertically upwards, when we are lifting an object vertically upwards, a force equal to its weight, a force equal to its weight, a force equal to its weight should be applied. A force equal to its weight should be applied on it. A force equal to its weight should be applied on it. Hari. එතකොට මෙතන instead of force I put W for weight and displacement is given as 4 meters. එහෙනම් weight or mg equals 180 divided by 4. That is 45. එහෙනම් mass equals 45 divided by 10. That is 4.5 kilograms. Harida, did you get? What is the mass of the object? Kela yahan. Hands up those who got the answer as 4.5 kilograms. Okay, good. Hari, most of you have taken. Well done. Right. Then we are moving on. Hari neda මොන හරි ප්‍රශ්න තියෙනවා නම් අහන්න. සමහර වෙලාවට මම මේ chat එකට දාන ඒවා ඒ වෙලේ දකින්නේ නැහැ. බලන්න මොනවද අහලා තියෙන්නේ කියලා. හරි මම අහලා නැහැ උත්තර තමයි ඒවල තියෙන්නේ. Okay. Okay. මොන හරි තියෙනවා නම් අහන්න. හරි. Shall we move on? Yes. Hey, mg equals 45 now. Weight is equal to mass multiplied by the acceleration due to gravity. Ne? G is acceleration due to gravity. So weight is 45. So mass into G is 10. That is why in order to find M, I divided 45 by 10. That is 4.5. Then Harida. Okay. Hari. Then complete the next table and I will show the table. Force, displacement of force and work done are given. Pen on the values. Here 10 Newton, 4 meters. Blank. Then 5 Newton, blank, 90 joules. Blank, 40 centimeters, 16 joules. කියලා තියෙන්නේ. Values pen on it. Those who don't have the tute. Hari. Kian. So you can just write the equation somewhere here. Work done equals force into displacement, right? Force into displacement. එතකොට 10 Newton, 4 meters. So the work done is 40 Newton meters or 40 joules. ඊට පස්සේ work done is 90 and the force applied is 5 Newton. So 90 divided by 5. That is, yes, that is 16 meters. 16 නෙවෙයිනේ. 18. 18 meters is the displacement. ඊට පස්සේ the work done is 16 joules. 16 joules can 16 Newton meters. Then the displacement of the force is given in centimeters. So you have to substitute in meters. එතකොට තමයි you will get the force in Newton. 160 divided by 4, that is 40 Newton. කොබලන් 40 Newton ගත්තද කියලා? Centimeters convert කරලා තියෙන්න ඕනේ. For that you have to be mindful නේද? 40 centimeters දැම්මොත් වරදිනවා. Right. That is about the work done. Right, good. Then we have to discuss about the energy. Now, you mentioned that energy is the ability to do the work, right? So there are different forms of energy. Then අපි grade 6 වල කතා කරලා තියෙනවා the sources of energy and forms of energy. Two different things. The main source of energy is the sun, right? There are sources of energy and there are forms of energy. Forms of energy, sound energy, light energy, heat energy. These are the forms of energy. Here we are going to discuss about the forms of energy. Hari. Now you can say energy is the ability to do the work. Energy is the ability to do the work. Energy is the ability to do the work. So unit of measuring energy is, what is the unit of measuring energy? That is joule. We symbolize it by capital J. There are different forms of energy. So you can say light energy, heat energy, kinetic energy, potential energy, which we collect, yes, sound energy, potential energy and kinetic energy together, kinetic energy කියලාත් කියනවා. These two are together known as the mechanical energy, right? Mechanical energy. Then you can say heat or the thermal energy. Heat or thermal energy. Magnetic energy. Electrical energy. Electric energy. So these are different forms of energy. Electric, magnetic, heat or thermal energy. Hari. This mechanical energy, we can divide it into two types. One is kinetic or the kinetic energy, right? Then the other type is potential energy. Potential energy. So this potential energy is of two types. එකක් තමයි Gravitational potential energy. Gravitational potential energy. And the other type is elastic potential energy. Elastic potential energy. Gravitational potential energy and the elastic potential energy. So first we are going to discuss about the kinetic energy. Hari. So what is this kinetic energy? Kinetic energy is the energy possessed by an object due to its motion, right? Energy possessed by an object due to its motion is called kinetic energy, right? There are two factors on which kinetic energy depends, right? There are two factors on which kinetic energy depends. Those are the mass of the object and the velocity. So you can write mass of the object and the velocity. Hari. Present a simple activity to show the effect of above two factors. Actually, we can say something like this. A simple activity. We can take a trolley, right? Which is kept on a table in the laboratory. Right? So we'll say it's the same trolley, right? So a ball is passed through this towards this trolley in a velocity of v1, right? In the next instance, the same you observe the now what happens when this ball comes and hit the trolley will move. So you can see, you can just get an idea about the kinetic energy obtained by the trolley, right? So we'll say the mass of this ball is m. Then the same trolley is there at the initial position once again, and you send the same ball with the mass m at a velocity of v2, right? And we'll say v2 is greater than v1. Now what will happen to the kinetic energy gained by the trolley? Yes, the kinetic energy gained by the trolley. In which instance is it greater? So I will say this is instance A and instance B. So energy transferred to the trolley. Energy transferred to the trolley is greater in blank. In which instance? Yes. Is it A or B? That is instance B, because the same ball travels at a higher velocity in the instance B. In B. It is clear that velocity affects the amount of kinetic energy. Then the next instance, the same trolley, you send a mass of the same mass at a velocity of this is instance x scalar. at a velocity of v, right? In the second instance, towards the same trolley, you have sent a mass of capital M at the same velocity, right? Capital M is greater than simple m here. And in which instance? Energy, this is Y. Energy transferred uh, to the trolley is greater in blank. In which instance? Yes, energy transfer to the trolley is greater in instance X or Y. That is Y, because the mass of this ball is greater. Therefore, it transfers more energy to the trolley. And it is clear that the kinetic energy is affected by the mass of the object as well. So, the energy of the ball is transferred to the trolley. In all the four instances, the energy of the ball is transferred to the trolley. Harineda, take it down. So remember, kinetic energy depends on the two factors, mass and velocity. Actually, we don't need to derive the equation. ඔයගොල්ලන්ට derive කරන්න කියලා නැහැ. We can just write the equation for kinetic energy. And that would be the second equation in this lesson. හරිද? Okay. Hari. Shall I clear the things? And then we have to move on to the equation on kinetic energy. Erase කරනවා. ඉවරද? හරි. ඔන්න the equation for kinetic energy. So we can represent kinetic energy as EK. Right? Kinetic energy is equal to half mv squared. This is the equation for kinetic energy. So EK is kinetic energy, which you obtain in joules, right? In joules. Then m is the mass of the object, which you have to substitute in kilograms. Then v is velocity of the object, which you have to substitute in ms minus 1 meters per second, right? Then do the first two calculations quickly. Yes, do the first two calculations. Right? හරි. බලමුද? Mass of an object is 8 kilograms. Calculates its kinetic energy when it is moving in a velocity of 2 ms minus 1. So you can say this kinetic energy equals half mv squared. Write the equation always. So half into mass is given as 8 kilograms. Then velocity 2 squared, right? So 4. 2 into 2 is 4. 4 into 4, 16 joules. 16 joules. Okay? Harida. Then find the velocity of an object of mass 2 kilograms when it possesses a kinetic energy of 36 joules. Yes, and once again you have to write the equation Ek equals half mv squared. So kinetic energy is given as 36 joules, half into mass is given as 2 into v squared. So the 2 and 2 get cancelled. V squared equals 36. Therefore, V equals the square root of 36. That is 6 ms minus 1. Right? 6 meters per second. Six ms minus 1. Avada, did you get the answer? හරි. එහෙනම් ඔන්න ඊළඟ ටික ටියුට් එක නැති අය print out එකක් අරගෙන you can do the third question for homework. Right, kinetic energy last question for homework. Then ගොඩාක් වැඩ ඉවර වෙගෙන එන්නේ. So you have to revise the things. අපි assessment එකකුත් තියන්න ඕනේ in the class. Right, after finishing all the lessons. So the assessment නම් හැමදාම ඒ කියන්නේ you are facing questions in the paper class. But we have to do some revision as well. Revision තමයි paper class එකේ කරන්නේ. තව ටිකක් කරන්න ඕනේ. Right, we have then අපි 17th skip කරලානේ ආවේ ඊළඟ දවසේ 17 and 18 both we will try to finish within the 2.5 hours. එතකොට on that extra class, extra නෙවෙයි in the cover up class, so we will start the 19th lesson. මම institute එකත් share කරන්න. But we have 19 and 20 only. 19 and 20 bit lengthy, electricity and genetics. හරි නේද? එනවන third question do for homework. Homework එකක් හරි දුන්නාම එතකොට ආපහු බලනවනේ මේ ටික. Tuts තිබුණ නැති අය just write the get the print out and get the answers completed, right? Hari. Emanang, see you on next Saturday. Paper class early in the morning and theory class at 9:30. Hari. Okay, stay safe and have a nice time. Okay, bye.